example 7. Example 7 is continue from example 6. Okay. Find the coordinate of the stationary point of the curve y equal to negative x cubed plus 9x squared minus 15x plus 11. And hence determine the maximum and minimum point. Okay, from this question, the stationary point we already get in example 6. You can refer back to example 6 to get the stationary point. From example 6, we already get the stationary point, which are 5, 36 and 1, 4. Okay, so now we have to test whether the point is maximum or minimum. To test whether the point is maximum or minimum, we use the first derivative test. Okay, now we come to the point 536 first. Okay, at 536, where the x is equal to 5, so we want to test this point. Before we test, we have to get the dy dx, which is a gradient. So we are given the function y equal to negative x cubed plus 9x squared minus 15x plus 11. So the dy dx is equal to negative 3x squared plus 18x minus 15. Okay, so now we are using the first derivative test. To use the first derivative test, first of all, we draw a table. After that, we can label the first row by x, the second one by dy dx, and then slope. Okay, so now we want to test at the point 5. So 5 we can put at the middle column, and then the column before 5, we can choose any number which is less than 5. Okay, I denoted it by 5 negative. Means you can choose 4 or 3. Okay, so the column after 5, you can choose a number which is greater than 5, maybe 6 or 6.5. I denoted it by 5 plus. Okay, so now we can substitute the number x into our dy dx to see the gradient, whether the gradient is positive or negative. Okay, so if we substitute a number less than 5 into our dy dx, means 4, we will get the answer positive. Okay, when we substitute 5, you will get 0. When we substitute a number greater than 5, for example 6, into our dy dx, the gradient we get is negative. Okay, so the positive means the slope will increase. Then 0, horizontal, and then negative is decrease. So from this table, we can conclude that the stationary point 536 is a local maximum point. The next step, we test the point 1, 4. Okay, so when the x is equal to 1, we have to test whether it's a maximum or minimum. Okay, so just now we already get the dy dx is equal to this. Okay, so to test a point, the same thing, we have to draw a table, and now we put the 1 at the middle column and a number less than 1 before the column 1, and then the number greater than 1 after the column 1. Okay, so now we can substitute the number into our dy dx. When we substitute 1 minus, for example 0, okay, the number less than 1, 0, when we substitute into our dy dx, we will get a negative 15, which is negative. Okay, so when substitute 1, you will get 0. When substitute 1 plus, for example 2, you will get the value positive. So it means that the slope is going down, horizontal, and going up, increase. Okay, so we can conclude that the stationary point 1, 4 is a local minimum point.